Okay, so here are your notes 2.3. Objectives in this one. It's for my honors class, by the way. I'm going to intro you guys to the three common forms of a linear equation, and hopefully you'll be able to graph a line from all three forms by the end of this lesson. So just being able to identify the forms and then being able to graph it once you can identify them. It's basically the goals of this lesson. All right, so moving on. We did this in class. Basically, this part was the general form of the point slope. This part was the slope-intercept form, general form of the slope-intercept form, and the general form of the standard form. So we made equations with the numbers actually filled in. So in standard form, your A will be filled in, your B will be filled in, your C will be filled in. So in this part, A was a 4, B was a 3, C was a 9. We said slope-intercept form is probably your more familiar one that you guys have. And in this one, your slope will be filled in and your y-intercept, also known as the B, will be filled in. So here your y-intercept is a 7. Here your slope is a negative 1/3 from what we said in class. Y-intercept also, just to make sure you guys know, the point that is 0, 7. So when you plot it, you would plot 0, 7, or just go up 7 on the y-axis. Point slope form, y minus y1 equals your slope times x minus x1. And one thing we said to focus on were these minus signs in the general form, which mean opposite. So in this one, we have what's essentially a -6, but we want the opposite of it because your y1 is actually a +6. If you plug a +6 in here, then it becomes a -6. Same thing here, this is a +7, but the only way to get a +7 is if your x1 is actually a -7, because a negative minus a -7 is a +7. Okay, so let's move on to this, tips for graphing. So we went over that in class. Graphing point slope form. So point slope form, like it says, you'll have a point, you'll have a slope. So the point is your actual, so first step is to find a point. So the point is actually your x1 and your y1. That is the piece of this formula or equation that you need to find the point. And then your slope is your second, you use your slope, which is the m part, to find a second point, and then you sketch your line. So let's get into this. So identify a point, slope, then graph. So the point here, and then, so we're going to find a point, and we're going to find the slope. So if we think about this, this is y minus y1 equals m times x minus x1. All right, so we said the point is x1, y1. So x1 lines up with this 3 right here. Okay, so that's a -3. But remember, you're supposed to take the opposite because you're trying to figure out what you plug in for this x1 to get this out. So your x is actually a 3. Your x1 is a 3. Because if you plug in 3 for x1 up here, then that will say -3. This is a +5, but remember we got to figure out what y1 is. So the only way you can get a +5 out of this general form is if y1 is actually a -5. So you just switch signs, essentially. So this -3 with the x turns into a +3. This +5 with the y turns into a -5. These signs don't have to be opposite either. This could have been a +3 and a +5. It could have been a -5 and a -3. They don't have to alternate. And then your slope is 2/3. So keep in mind, slope is like a map to a second point. So the top number tells you where to go vertically. So that would go up 2 because +2, 3 on the bottom means you're going to go right 2. All right, so let's do a dual page and graph this thing. All right, so starting the graph at your point. So we're going to put this point in right here. So 3 -5 is over 3 down 5. So plotting that point right there. Okay. Now, when you have the slope, make sure you use it like a map. It's like your GPS to find your second point. This is your starting point. You have to find a second point to make a line. So this is telling you directions. You have to go up 2, then 3. Kind of like a GPS, you're going to go up 2 blocks and then right 3 blocks. So starting here, think of this like a little car. It's moving along these streets. You're going to go drive up 2 blocks and then drive to the left, or sorry, right 3 blocks. So your next point should be right here. Point correctly. And there you go. Minimum points you need to draw a specific line is 2. Just go across, and there you go. You don't have to label it only because there's only one line here. Once we start graphing more than one lines, then I will start making you guys label your lines. All right, so let's go ahead and go single page again. Moving on. Slope-intercept form. This is probably more familiar to you guys. Most of the time in geometry, you're using this form of a line. The m is your slope, b is the y-intercept. Plot the y-intercept first. So obviously you got to find your y-intercept first. And then after that, you're going to use the slope, which is m, to find a second point. So here we go. So find the slope and the y-intercept, then graph. So your slope equals mx plus b. So it looks like your slope lines up with this 1/2. So your slope must be 1/2. And your b lines up with this 1, so your y-intercept, also known as b, is 1. If you think of this as an ordered pair, this would be a 0, 1. All right, so just like before, you plot the y-intercept, or your y-intercept is actually a point, and then use your slope to figure out where the next point is. This is saying going up 1 and to the right 2. So let's bring up the dual page again. There's the dual page. Graph. Where are you? There they are. Okay. So 0, 1. So starts at 0, go up 1. So there's, so 0, 1 is right there. Okay. Now we use the slope just like last time. We're going to go up 1 unit and 2 to the right. So up 1 and 2 to the right will get us right here at 2, 2. That's enough for a line. If you want, you could do 2, like however many points you want. So you can go up 1 and over to the right 2 again, up 1, right 2 again, up 1, right 2 again. All that will ensure is that your line is a little bit straighter than it would have been with just 2 points. Try to use a straight edge if you can. And there you go. Next one. Trying to get through this faster. My other video took a long time, so. Graphing in standard form, there's 2 ways to do this. I will accept either way, but you do have to show me. If you pick this first way, then you have to show me what your x-intercept and your y-intercepts are before you graph. If you choose the second way to graph, then you have to show me what your y-intercept is and what your slope is. Oh, forgot to put standard form up here. So standard form is ax plus by equals c. All right. So the y-intercept can be found by taking c and dividing it by the b value, or the value in front of the y. The slope can be found like this. And I think in one of my classes I went over why this happens. So basically, so I'll go over it real fast. So let me do it up here. So ax plus by equals c. If I were to solve for y, I'd have to subtract ax, and I'll get by equals negative ax plus c. And to get rid of the b, I gotta divide by b, whole side. So y equals negative a over bx plus c over b. And if you think about this, if you think about slope-intercept form, y equals mx plus b, or lowercase b, sorry about that, lowercase, okay? B matches up with c over b, which means that your y-intercept is c over b, and this a over b matches up with your slope, which means your slope has to be negative a over b, okay? And that's how that works. So moving on, let's go ahead and do an example of this one. So I'll do this 2 ways. Notice this says find the slope and y-intercept, or identify both intercepts then graph. So you're doing one of these 2 things to graph. I will show this both ways though. To find, we'll do x and y-intercepts first. So x-intercept, y-intercept. So to find the x-intercept, you need to plug in 0 for y. If you plug in a 0 for y, this will say negative 2 times 0, which will make this entire thing a 0, which means that when you take a 3x and you subtract a 0, you just get the 3x back. So essentially, I don't want to say cancel, but I will anyways. You're canceling this out, and you'll get a 3x equals 6. So for the x-intercept, just focus on the x part. You don't have to worry about the y part because you have to plug in a 0 there anyways. So your equation that will result is 3x equals a 6. Now for your y-intercept part, you're doing something very similar. Instead of plugging in a 0 for y, you're plugging in a 0 for x. Basically, that will zero out this x. You'll get negative 2y equals 6. For your y-intercept, now you just have to accomplish solving both of those. Divide by negative 2 here. You'll get your y-intercept is a negative 3. That's a point on its own, 0, negative 3. Okay. On this side, you're going to divide by 3, so x equals 2, or 2 comma 0. So that is one way you can do this. We'll plot it all at the same time. The other way you can do this, so this is using intercepts. On this other side, we're going to find the slope, and we're going to find the y-intercept. So if you remember, the y-intercept is actually going to be your c over your b. So that's going to be 6. Uh-oh. Okay. I need to wait till this starts back up. All right. Sorry about that. Little technical difficulties. So the y-intercept is basically going to be 6 over negative 2, which is a negative 3. So once again, that matches up with the other side, so that's just a negative 3, because it's c over b. The slope is going to be negative a over b. So that's going to be negative 3 over b, which is a negative 2. Okay, so I put this negative symbol on the top number, which was the 3. And then over b, which was a negative 2. So basically, it's going to be 3 over 2. All right, so let's see if that actually works out. I hope it does. Blah, blah, blah. Here we go, dual page. So you have to show one of these two for your work in the end. So let's do this one first. I'll graph this one in red. So 2, 0, that's going to be right 2. And then 0, negative 3, that's going to be down 3. And then you draw your line. Oh, hopefully your line looks better than that, though. Yeah. All right. Let's fix this. All right. I'll do the other one in green. So the other one says you start at negative 3, so that's where you'd start that one. Then you go up 3 and over 2, which means you end up in the same spot and you get essentially the same line. So as you can see, they both are valid ways of graphing the same thing. So it's up to you which one you want to do, but you do need to pick one of these methods. I don't want you turning this into another format and then graphing that way. Even though that is a valid option, I want to see if you guys can handle just looking at it and actually graphing from this form itself. Okay. All right. So, like I said, you can transform it into another form if you would like. That's what this one says. So, hold on. Okay, so you can always transform into another. So if you look at it right here, this one, you will have work on this, by the way. This one's starting off in point slope form. If you want to change it into slope intercept form, it's just a matter of solving for y. But slope intercept form doesn't have parentheses. So you might want to start this off. You can start this off in actually in a couple different ways. I would probably start it off by distributing. So I want to distribute the 1/5 to both of those parts. Just going to get y plus 4 equals 1/5 times x is 1/5 x. 1/5 times 20 is basically going to be 20 divided by 5, which is a 4 times a 1, so plus 4. Okay. Now we have to subtract 4 from both sides, and you'll get y equals 1/5 x. There you go. This would be slope intercept form. Your y-intercept in this case, since 4 minus 4 is a 0, your y-intercept is actually going to be at the origin 0, 0. Um, Now, as far as standard form goes, um, so standard form, you need to get the x and y on one side. Now, standard form, you would do the same amount of work as the slope intercept is one way of thinking about this. Let's see here. So, I'm trying to figure out the best way that, or the easiest way to kind of think about this. Um, So let's go ahead and just take this since we already worked with it. So it's y equals 1/5 x. Now standard form says it's ax plus by equals c, but a, b, and c need to be whole numbers. So that this 5 on the bottom is bothering me. So what we're going to do is we're going to do a fraction buster and multiply both sides by 5. So multiplication property of equality says we're allowed to do that. So we're going to do 5 times y equals 1/5 of 5 is 1, so just an x. Now that that's gone, I want to get my x's and y on one side. So I'm going to get negative x plus 5y equals x minus x is 0. So your c actually ends up being a 0, but that is standard form. All right, so that's how you would switch them. You would just solve it out. Basically, you get it in slope-intercept form, you would isolate your y. To get it in standard form, you would get your x's and y's on one side and make sure there's no fractions. If there is a fraction, you got to do a fraction buster. Last one. Vertical and horizontal lines are kind of special cases. In order to graph, there's one of two methods. Either memorize and know that if you guys have x equals some constant number, that is always going to be a vertical line. If you have y equals a constant number with no variables, just a constant number like a y equals 7 or something like that, that's going to be a horizontal line at whatever that number is. Second method is to find 2 points. So I'll show you this on this one right here. Okay, so let's say I wanted you to graph y equals 3. So the first method would be to memorize, okay, this is y equals a number, and then you have to memorize that y equals means it's going to be horizontal. So you'll know right away that it's a horizontal line going side to side, and then you would graph a line going side to side at 3. That's kind of a lot to remember, and people usually get kind of mixed up because they'll see y equals 3, and they end up putting it in the wrong spot for some odd reason. The way that I usually try to think about this is think of this as a statement. You know you need 2 points, so let's put 2 points on here. There's 1 point, here's 2 points. And this is your rule. The rule says y has to be a 3. Okay, so these are my y values, so those have to be a 3. So there you go. My y's are 3s. Now, since this statement says nothing about your x's, you can pick any number you want for your x's. Whatever you want. Any number here and any number there, because no matter what you put in for the x's, it does not violate the statement that y is 3 because you just made your y's equal to 3. So I'll make this a 1 and a 4. Okay, you can make them negatives, you can make them whatever you want. So once you have 2 points, you can make a line, and you don't have to memorize which way that line's going because you just have your 2 points right there. So I'll make this little page, graph it. So my 2 points I found was 1, 3, so you're going to go right 1 and up 3. Second point is 4, 3, so I'm going to go over 4 and up 3. And there's your y equals 3 line is going across right here. Actually, let me make that in another color here. There you go. So you have a horizontal line going side to side. So like I said, either you memorize that y is a horizontal line and then go up to 3 and then go side to side, or just quickly do 2 points and make sure your y values are 3, pick whatever you want for your x's, and you'll end up on the same line. Okay, and that is it. 19 minutes, and you probably should have fast forwarded through a lot of this stuff because we did it in class already. Okay, you'll get a worksheet tomorrow on this, and we'll do a work day tomorrow. All right, bye-bye.